How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss one of the topics in the senior high school. So, this is all about evaluating functions. So before anything else, hit the subscribe button and notification bell for you to be updated of the School Clear Math videos just like this. Hello math learners! Welcome to another session here in ML with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for the senior high school general mathematics, which is focused on evaluating functions. Now, the question is, what do you mean by evaluating? Evaluating is technically substituting a certain value to a given function. So, what we do here is that we tend to input a certain value to the given function and then we simplify it. That is what we mean by evaluating. Now, what do you mean by function? Function can be represented into equations, in which this equation has two variables. The first variable is what we call the x, and the second variable is known as the y. However, this x stands for as the domain, while the y stands for as the range. The domain and the range. Now, this domain is the one who will lead the function. Regardless of what value is being given, the domain is being the one to be changed and the dependent variable will be the y. Now, as you can see here in our example, we have x, right? We have x. Now, that will serve as our domain, while this will be represented as our y. Now, in most cases, our y is being changed into the function of x. Now, this function of x can either be represented by any letter. It could be f, g, p, f, g, and other letters. Okay? So, therefore, the thing that we are seeing in the left side of this function is what we call the range, while in the right side is the equation itself, or the expression itself in which domain is there. Okay, now, remember that in order for a certain equation to be a function, it should have a what we call one-to-one correspondence or many-to-one correspondence. Now, what do I mean by this? It means that there are only a certain value of x in which the value of y will be dependent on it. That is what we call one-to-one correspondence. Sometimes, there are a lot of values of x, but the value of y will still be the same. Meaning, there are a lot of domain, but there is only one range. That is what we meant by many-to-one. Okay, but more on that. Now, let us talk about evaluating functions. When we evaluate functions, we tend to substitute the certain value being asked. Okay, now we have here an example. Example number 1. F of x is equal to 2x minus 4. Now, the problem is that find x is equal to 3 and find f of x or f of 2x minus 3. What do we mean by this? It means that this is our function and we will input our 3 to the function. As well as, on the next part of the solution, is we will input 2x minus 3 to our function. Okay, so now let's start. How do we solve this one? So first is you write the function. So that is 2x minus 4. Then we try to solve it. The first problem, x is equal to 3. So we put f of 3. Okay, the function of 3. Now, by doing so, what we do is we substitute our x here with 3. And then we simplify. So what we do here is f of 3 is equal to 2 times 3, that is 6, minus 4. And the final answer is 2. Therefore, if your domain is 3, the value of your f of x is 2. Okay? So that is how the function goes. Okay? I hope you got that one, my dear math learners. Now, let's go to the second problem. Okay, in doing f of 2x minus 3, what you will do is, you will change x here into this whole expression. So that will become 2, which is 2, alright? And then, we change x into 2x minus 3. Then, you copy the other remaining terms. Okay, minus 4. So, as you can see here, our x here is being replaced by our input value, which is the value of x. So, that is 2x minus 3. Okay? So, now, let us simplify. So, by simplifying this, we just use the distributive property, and that is 4x minus 6 minus 4. So, we have 4x, negative 6 minus 4, that is negative 10. So, therefore, our value of f of 2x minus 3 is equal to 4x minus 10. Now, if you ask me, Sir Ash, is this the final answer? Yes, that is the final answer for this problem. And for this problem, our answer is 2. Easy, right? Now, let's go to the second example. Okay, math learners, second example is g of x is equal to 3x squared plus 7. And what we are asked to find is the g of negative 3, meaning the function of negative 3. Okay, so now, what we do is, first we write our function, original function, okay? And then, we substitute our x by negative 3. So, technically, we also substitute it into our expression here. So, that is negative 3 squared plus 7. Okay. Now, how do we simplify this? Remember that in simplifying with an exponent, we always follow the PEMDAS rule, meaning the parenthesis, exponents, multiplication, division, addition, and subtraction. So, first we need to do here is to use this negative 3 to the power of 2, or negative 3 squared. Not 3 times negative 3, my dear math learners, alright? So, first we do this one. So, that gives us positive 9, because negative 3 times negative 3 is positive 9. Okay, then we add our plus 7. Then, what we do is the multiplication. So, that gives us 27 plus 7. And if we add 27 plus 7, that gives us 34. So, our g of negative 3 is 34. Easy, right? Now, let us go to the third example. Okay, math learners, we are here in our third example. We have p of x is equal to 3x squared plus 5x minus 2. Now, what we are owed to find is the value of 0 and the value of negative 1, or p of 0 or p of negative 1. Okay, so how do we do this? The same process, we write our original function, and then we substitute our p of 0. Okay, so by doing so, that goes as 3 times 0 squared plus 5 times 0 minus 2. So we follow the PEMDAS rule. So we have 0 squared is still 0. 0, okay, so that is 3 times 0. 5 times 0 is 0 minus 2. Okay, so 3 times 0, that is 0. 0 minus 2, that is negative 2. So therefore, our final answer is negative 2. Okay, so p of 0 is equal to negative 2. Now, the question is, what is the p of negative 1? So for the p of negative 1, what we do is, still we use our original function. We change our x by negative 1, okay? That is plus 5 negative 1 minus 2. So we have negative 1 squared, that is positive 1, because negative 1 times negative 1 is positive 1. 5 times negative 1, that is negative 5. Alright, minus 2. So we have here 3, negative 5 minus 2, that is negative 7. Alright, and 3 minus 7 is equal to negative 4. So therefore, the value of p negative 1 is negative 4. And the value of p to the 0, or p of 0, is negative 2. Easy, right? Now, let us go to the fourth example. Okay, math learners, down to our fourth example, we have f of x is equal to 5x plus 1. Question is, find f of h plus 1. Okay, so, as you can see here, it's very the same as our first example earlier, because our value of x is being changed or being given a value of h plus 1. Though this is not a value, but this is an expression. Okay, so what we do is, we copy our original function, and then we change our x by h plus 1. Same goes, if we change that one, that also affects our right side of the equation, therefore giving us h plus 1 plus 1. Okay, so now, the same process, we distribute it, because h plus 1 cannot be added together. So 5h, 5 times 1, that is 5. Then we copy plus 1. Now what we do is we simplify like terms. 5h There are no other terms with an h here, so we copy the 5h. 5 plus 1, that is 6. Therefore, our final answer is 5h plus 6. Easy, right? Now, let us go to our fifth example. Okay, math learners, we are now in our next example. We have g of x is equal to the square root of 3x minus 2. The question is, find g of 9. What do we do here is we change our x with the value of 9. So, therefore, that is still very easy because we just input our value of 9 to our expression. So, that is g of 9 is equal to 3 times 9 minus 2. Okay? So, we copy this one. Our x is being changed by 9. And then, we copy the minus 2. And also, we copy the square root symbol. Okay, or the radical sign. Now, we simplify this one. 3 times 9, that is 27. Minus 2, that gives us 25. Square root of 25. Question is, can we simplify square root of 25? Yes. Because the square root of 25 is, alright, very good. That is 5. So, the g of 9 is equal to 5. Easy, right? Now, let us go to our next example. Okay, math learners, we are now to our next example, which is a fraction or a rational algebraic expression. Okay, so we have h of x is equal to 4x plus 8 all over 2x minus 4. And the value of our x is negative 5. So, how do we do that? First is, we copy 4x plus 8 over 2x minus 4. Then, we substitute our x with 5. So, that gives us 4 times negative 5 plus 8 divided by 2 times negative 5 minus 4. So, what do we do here is we simplify. So, 4 times negative 5, that is negative 20 plus 8. Alright? 2 times negative 5, that is negative 10 minus 4. So, by simplifying this, negative 20 plus 8, that gives us negative 12. By simplifying negative 10 minus 4, that gives us negative 14. They are both negative, so the negative and negative can be cancelled, giving us 12 over 14. However, 12 over 14 has a lowest term, and that is by the use of the greatest common factor, which is 2. So, by using 2, 12 divided by 2, that is 6. 14 divided by 2, that is 7. And this is our final value for our function if x is equal to negative 5. Now, regardless of a fraction or not, it's still easy, right? Now, let us go to our next example. Okay, math learners, we are now in our second to the last example. We have f of x is equal to 2 to the power of x. And what we ought to find is what will become the function if our x is equal to 3 halves or 3 over 2. Now, what we do here is still the same. We copy the original function and then we change x into 3 over 2. By doing so, we have an exponent that is a fraction. Now, how do we change this one? Remember that if you have a rational exponent, what does it mean is that your denominator becomes a root while your numerator becomes its new exponent. So, therefore, if we transform this one, this will become square root of 2 cubed. How did it happen? This 2 here will become the root, square root, that is 2. And our numerator is the new exponent. So, we have square root of 2 cubed. Now, what is the simplification of the square root of 2 cubed? So, 2 cubed means 2 times 2 times 2. And the answer is 8. Because 2 times 2, 4 times 2, 8. Okay. Now, we have square root of 8. Question is this our final answer? Not yet, my dear math learners. Because square root of 8 can still be broken down into pieces and can obtain its simplest form. How do we do that? We factor this out to its perfect squares. So, the perfect square of 8, in which one factor is a perfect square, that is square root of 4, square root of 2. 4 times 2, that is 8. Why did I do this? It's because there is one factor that is a perfect square. And if that's the case, then you need to simplify it. By doing so, we have square root of 4, square root of 2. Now, what is the square root of 4? That is 2. What is the square root of 2? We don't know. Still, we just copy the square root of 2. And that will be our final answer for f of 3 over 2. That is 2 square root of 2. Okay? So, if you didn't get this one or you had a confusion about the process, do it step by step, okay? Or you can rewind this example, my dear math learners. Okay, now let us go to our final example if we have an absolute value. Okay, math learners, we are now to our final example. We have f of x is equal to the absolute value of x minus 8. And our problem is that we need to find f of 3 or the value in which our x is 3. Okay, so what do we do here? Same goes. We copy the function, alright? And then we change our x by 3. So that gives us 3 minus 8. So the absolute value of 3 minus 8. 3 minus 8, what's the answer? That is negative 5. Okay, so therefore, the result is the absolute value of negative 5. Now, the question is, what is the absolute value of negative 5? Alright, now the final answer is 5. Because in the concept of absolute value, regardless whether your number in the absolute value sign is positive or negative, we just take its value, and that is 5. So therefore, f of 3 is equal to 5. Okay, I hope you get the idea of how to evaluate functions. This topic is very easy, my dear math learners. And if you have some confusion about our topic, do not forget to comment in our comment section below. Now, this is the time that I will challenge you whether you have understood our topic, and here it is. Okay, math learners, I hope you have a wonderful time for today's session. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you for your support. Take care, God bless, and be safe always. Fellow math learners, if you think you like this video, hit the like button and the subscribe button. That is, if you are committed of learning mathematics the easy way. Thank you.